Hi guys. Hi guys. Okay, so as promised, I'm going to go over an example that hopefully will help you with your project. So this is a similar scenario to what you guys are going to be able to choose from, but obviously not the exact same one. So if you'll notice, we are trying to maximize revenue for a company. In this case, there's an airline. It's found that right now they sell about 8,000 tickets per month, and each ticket is $50, which, like, wouldn't that be cool? But yeah, whatever. So they do a survey and they find out that for every dollar that they increase the ticket price, the airline loses 100 passengers. So we're maximizing revenue, right? So what is revenue? Well, revenue is how much money they're bringing in. So in order to maximize that, we need to figure out what the revenue is. So generally, revenue, that's horrible handwriting, but that says revenue, is the number sold of whatever it is you're selling times, the price. That should hopefully make sense, like however many you sell times how much you're selling it for. So in this case, we are going to do let's start with the number sold. So right now we're selling 8,000 per month. But every time we increase it $1, we lose 100 patients. So I'm going to say minus 100 times X. Okay, so because every time we increase it, we're going to lose $100. So that's how much the number sold is going to be. Our price right now is $50. And we're looking at adding, how many times can we add $1? So obviously you could just write X there, but just so that you know where it's coming from, it's the $1 increase. So we're decreasing the number we're selling, but we're increasing the price, and we're going to see how much we can increase the price while we still make more money. So I'm going to put this in standard form, which is what we've been using more often. I think that it would look, on your presentation, you would want to use this equation to explain where it comes from. But just so that you know how to put it in standard form, you would multiply everything out. So basically, it's like distributing everything, but I recommend with two binomials that you use the box method. It's just a way to make sure you don't forget anything. So since it's a binomial and a binomial, I'm going to use a 2 by 2 box, and I'm going to put everything on the outside. 8,000 negative 100x, and then 50 and 1x. And it's just a way, like I said, to make sure that we don't forget anything. So 50 times 8,000 is going to be 5 zeros. 40,000. Am I wrong? I feel like I need another zero. 1. Oh, okay. I said 5 and I didn't write 5. Sorry. 400,000. 50 times negative 100x is going to be negative 5,000x. This 1x times negative 100x will be negative 100x squared. And then 1x times 8,000 will just be 8,000x. So my equation in standard form is going to be negative 100x squared plus 3,000x plus 400,000. Okay. So there's my equation. Ta-da. We have to know what x and y is. So let's look at how we made the equation, right? We said that y, we got y, we figured it out because we're looking at revenue. So in this case, y is going to be our revenue, okay? And that pretty much stands for any of these types of situations. For x, what we're multiplying by is like how many times we're increasing by $1. So X is, it might sound weird, but it is the number of price increases. Okay, so it's the number of times that we're going to increase the price by 1. So I am going to jump over to Desmos and graph this. So jump over here. So I have y equals, it was negative 100 x squared. Oh, this is GeoGebra, sorry. I'm not using Desmos. Either one works though. GeoGebra or Desmos. Plus 3000x plus 400, 3000. So obviously, I can't see my graph. What am I to do? But that is just because, the numbers are a lot bigger than what they zoom in. So here's going to be the tricky part. If you're on a touch screen, it's pretty easy where I can you can't see what I'm doing, but what I'm doing is I'm putting both fingers on the x-axis and I'm like you can't see, but I'm like spreading my fingers just on the x-axis apart. And then I'm going to do the same thing on the y-axis. So on a touch screen, you can zoom each like that. Now, with if you don't have a touch screen, right? If you're doing this on a computer, you are going to have to look at the settings and let's see. You can click zoom to fit and it'll fit. It should fit it in there. On Desmos, it's a little different. You have to type in where you want your X's and Y's to be. Okay, but whatever it is, if you're going to take a picture of it, you need to make sure that you see the whole parabola with all the intercepts and all that stuff. So anyway, okay, sorry. If you have trouble with that, I can help you during our first week back. So let's go back and see what we need. All right, so I need to know my y-intercept. So my y-intercept, the great thing about Desmos and GeoGebra is that if you click on it, it tells you. So the y-intercept is 0, 400,000. 0, 400,000. So in this case, you are going to have to explain what that means, right? So my hint on the it's called slideshow, whatever, Google Slides. My hint was a y-intercept is when x is 0. So what would it mean if, well, that arrow's kind of wonky. What would it mean if that was 0? So what does it mean if we didn't increase the price yet at all? Well, it means we haven't changed anything, right? So my y-intercept, that is how much revenue they're making right now. And in this case, it's monthly revenue. That could change. Depending on your situation, your scenario that you choose. But how much monthly revenue the company makes now. Okay, so now we're going to look at, no, where did it go? Y equals negative. It's going to be annoying if I have to type this in every time. 3,000 plus 400. Okay. Okay, sorry. Yeah. Okay. Oh, I forgot my X there. X. Enter. Change that. All right. So the next thing I need is my x-intercepts. So I have 80 and a negative 50. Okay. So at the risk of that disappearing again, I'm going to go down and talk about my x-intercepts. So 80 and negative 50 are my x-intercepts. So again, my hint was, what would it mean when y is 0? Because that's what an x-intercept is, when y is 0. So since y is revenue, that would mean that the revenue is 0. This is how many times they would have to increase the price so that like nobody would buy it anymore. Like everybody's just like, nope, too expensive, don't want it. So this would be the number, and like I said, you're putting this in a slideshow, so you're going to make it look nice and you're going to find a good way to explain it. But number of price increases to make it so expensive, no one buys it. Oops. No one buys it. So you could go further and say that to make any money at all, the price has to be between. Okay, and so let's go back and look. Our original price was $50. So if we increased it by $1.80 times, that would be $130. Well, and then obviously if the negative 50 would be decreasing it so that the cost was 0. So 100, it basically it has to be between 130 and $0. Or you could just say it can't be higher than $130. However you want to say it. Okay. So that is the x-intercepts. Now my maximum. I'm going to come back over here and, oh yeah, my graph is still here. Hooray. So my maximum is 15,422,500. So my maximum is 15,422,500. Maybe I'll take that comma out so it doesn't get confusing. Okay. So that means that this is the most amount of money that they can make. Okay, so basically, if we increase price 15 times, we get a max revenue, meaning like the most money that they can make, of $422,500 per month. Which, hey, that's a lot of money. Awesome. Okay. So from that, okay, so I've figured that out. I'm going to make a recommendation, and that is where I'm going to actually say, I recommend a new ticket price of, and then obviously in our case, it's a $1 increase, but remember that's not always the case. Sometimes you're increasing by $2. So you actually have to figure out what the actual new price would be. Okay, so be careful with that. It doesn't just mean you have that number. But in this case, it's going to be, I'll do it off to the side. So it'll be $50 to where you started. Okay. Starting price plus 15, which is my x, the x of my max, times 1, which is, price increase from the problem. And in this case, oh, you can't see what I wrote. Okay. That looks horrible. My handwriting's horrible. But hopefully you get the idea. So you take your starting price and then you add the number, the X of your maximum, and multiply that by the price increase from the problem, like how much they said they were increasing the price each time. And you multiply those together and add it to your original price, basically. So in this case, that will be 65. So I am going to recommend a ticket price of $65 to maximize the revenue, or you can say monthly revenue. But you want to make sure that in this presentation you explain where all these numbers are coming from. You know, that it's very clear, because a lot of times if you were to make this sort of recommendation, like clients they're not always number people. So like in this scenario, you are the mathematician, you are the number person, and you are explaining it to the normal people. So anyway, there you go. Hopefully this helps.